There's a famous equation that lives inside AI, and it goes like this: king minus man plus woman equals queen, not metaphorically, mathematically. If you take the numbers that represent king, subtract the numbers for man, and add the numbers for woman, you land almost exactly on the numbers for queen. That's not a party trick. It's a clue about how AI understands anything at all. Here's what most people picture when they think about how AI reads text. They imagine the model taking in words one by one, building up some sense of meaning as it goes, the way you do when you read a sentence. And they assume the understanding happens in that process, in the reading itself. So when AI answers your question, they picture it working through the language, finding the right words to match, consulting something like an intuition built from reading a lot. Some people go further and imagine a giant dictionary somewhere inside the model, or a knowledge base it looks things up in, like a very fast encyclopedia. None of that is quite right. The model does not work with words at all. Before a single word reaches the model to be processed, it gets converted into a list of numbers. And those numbers are not just a code, like a equals 1 and b equals 2. There's something stranger and more useful than that. That list of numbers is called an embedding, and it's not an arbitrary encoding. It's a position in a space with hundreds or even thousands of dimensions. Think of it like a map, but instead of having two axes, x and y, it might have 768 of them, or 1536, or more, each one representing some aspect of meaning that the model learned to track during training. A word doesn't get a random spot on this map. It gets placed based on every context it appeared in across billions of training examples. Words that tend to show up in similar situations end up sitting close together in that space. Words that rarely share a context end up far apart. And that placement is not decided by a human or by rules. The model discovers it entirely on its own, by noticing which words keep appearing near each other and which ones don't. So dog and puppy are neighbors in that space. Dog and cat are close but not quite as close, because while they share a lot of context, they show up in enough different situations to create a gap. Dog and democracy sit in entirely different parts of the map. And here's where the king minus man plus woman math actually comes from. During training, the model saw king and queen in similar contexts, and it saw man and woman in similar contexts. The difference in meaning between man and woman mapped onto a consistent gap in the training data. That same gap showed up between king and queen, between actor and actress, between prince and princess, again and again. The model's map learned that gap. So in that high-dimensional space, the vector pointing from man to woman points in roughly the same direction as the vector from king to queen. The arithmetic is measuring real semantic distance. It's geometry. This is also the same mechanism behind autocomplete suggestions that feel eerily appropriate, and translation systems that preserve nuance even when switching between completely different languages. Now, this is the part that feels almost like magic once you see it. Things that feel like genuine understanding turn out to be this geometry, applied fast. When you ask a model whether elated means something close to happy, it doesn't look it up. It checks whether those two embeddings sit near each other in the space. They do, so the answer is yes. When a search engine finds articles similar to one you just read, it converts that article into an embedding and looks for other documents whose embeddings land nearby, even if they share no words at all. When an image model connects the word dog to photos of dogs, it's because both the word and pictures of actual dogs were trained to cluster in the same general region of the embedding space. Embeddings are the common currency everything gets translated into before any real computation happens. Not just words, sentences, paragraphs, images, audio clips. Everything going into a modern AI model passes through some version of this translation first. One thing that trips a lot of people up: an embedding is not fixed for a word, at least not in modern models. Early systems gave each word one single embedding, period. One fixed set of numbers, no matter what surrounded it. So bank as in riverbank and bank as in financial institution got identical embeddings, which caused real, persistent problems. The model couldn't tell them apart from the numbers alone. Today's transformer-based models compute embeddings in context. The embedding for bank shifts depending on everything around it. If the surrounding words are about rivers and rainfall, the numbers shift one way. If they're about loans and interest rates, they shift another way entirely. The model isn't looking up a fixed point on the map. It's computing a new position based on all the surrounding context for every single token in your input. all at once, before a single character of the response is generated. It is a lot of calculation, done very fast on every word you write. So what does any of this mean for how you actually use AI? First, phrasing matters in a way that isn't obvious from the outside. Two questions that look completely different to you might land in nearly the same region of the embedding space, so the model treats them the same way. And two questions that look almost identical can point at meaningfully different regions, which is why rewording something sometimes gets you a completely different answer. The model isn't parsing grammar the way you might expect or scanning for keywords. It's navigating that high-dimensional map, and where your words land is what determines what comes back. Giving the model more context around your question usually helps, because more surrounding words shift the embedding computation toward a more specific region of the map, and a more specific region gives you a more specific answer. Second, embeddings are what powers the memory features in tools that remember you across sessions. When an AI app saves notes from past conversations and surfaces them in a later chat, what it's actually doing is storing embeddings of those past exchanges. Then at the start of your new conversation, finding the stored embeddings closest to what you just said and pulling them back into the context. It's not a filing cabinet. It's a nearest neighbor search on a high-dimensional map, running every time you open a new chat. Third, semantic search, the kind that finds documents by meaning rather than by exact word match, runs entirely on embeddings. You type a question, it becomes a set of coordinates in the space, and the search returns documents whose coordinates are nearby, even if those documents share no literal words with your query. That's how you can search for how to stay calm under pressure and get back an article about managing stress, with neither the word calm nor the word pressure appearing anywhere in the document. The geometry picks up the similarity that keyword matching would completely miss. All of this matters because it reframes what AI is doing at the most basic level. It isn't reading language. It's doing geometry on a map of meaning built from patterns across an enormous amount of text. And that map captures a lot. Relationships between concepts, analogies, categories, degrees of similarity, the gap between formal and informal registers, the difference between describing a place and describing a feeling. But it also has gaps and distortions, places where the geometry breaks down or bends in ways that reflect the biases in the training data. Some things that feel related to you sit far apart on the map. Some things that seem unrelated end up strangely close. When you know the map is there, you start to understand the model's behavior for what it is. A very fast search through a very large geometric structure, always looking for the coordinates that fit. It's a remarkable thing to grasp, because it means everything the model knows is really a shape, and everything it does is navigation through that shape. So the next time you type something into an AI, your words aren't really what it's processing. They get converted into coordinates, positions in a space of meaning built from billions of examples, and everything from there is geometry. It sounds abstract, but it's the foundation for nearly everything AI can do, from answering questions to finding similar content to generating language that actually sounds like it makes sense. That invisible map is doing a lot of heavy lifting. And that is exactly what we do here, one clear idea at a time.